Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to go over a couple more practice problems on how to write orbital diagrams for elements. So in these two problems they're asking for an orbital diagram for an element, and then they ask you for the number of unpaired electrons. This is where following Hund's rule is going to be very important, because if you don't follow Hund's rule you're going to get this problem wrong. Okay, so the first problem is asking you to write an orbital diagram for sulfur. So we need to know how many electrons sulfur has. So we look it up, and sulfur has 16 electrons. So if we're going to do our orbital diagram, 16 electrons, remember the 1s is the lowest, followed by the 2s, and then you have the 2p, and then you have the 3s, and then you've got the 3p, and then you've got the 4s, and then you've got the 3d. Oops, bring this down. Let's bring this down a little bit lower. So 4s, and then you've got the 1, 2, 3, 4, 5, 3d. That should be enough for this problem. So we have, again, 16. Let me double check again. So sulfur, yes, 16 electrons. So the way you're going to build up your orbital diagram is to start at the lowest energy level and give electrons to all the orbitals starting from lowest to highest. And so each line represents an orbital. This is a sublevel, this is a sublevel, this is a sublevel, this is a sublevel. So different sublevels have different numbers of orbitals. So here we have one orbital, so spin up, spin down, 2 electrons there. The next one is 2s, spin up, spin down there, so that's 4, 12 more to go. So following Hund's rule, it's spin up, spin up, spin up. All have the same spin, 1 in each orbital first, and then you start turning them up. Spin down, spin down, spin down. So that's 10 electrons, 6 more to go. So now we're going to go to the next one, which is 3s. So spin up, spin down. So there we have 12. And now we have 4 left, and we're gonna go to the 3p. So again, following Hund's rule, spin up, spin up, spin up, and that's 3. We have 1 more, spin down. So if we count them, we should have 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this is the orbital diagram for sulfur, and the number of unpaired electrons is 2. Now, if you didn't follow Hund's rule, then you might have paired them like this, and then your answer would be no unpaired electrons, which would be false. So this is why it's very important to follow Hund's rule. Okay, so 2 unpaired electrons. So this is the orbital diagram for sulfur. In some books, maybe in your book, you will sometimes write them out in a straight line. So you'll have your orbitals, like your orbital diagram like this: 1s, 2s, 1, 2, 3, 2p, and then you have your 3s, 1, 2, 3, 3p. So this is, you could write it like that, I guess. I don't really like it that way because I like to see that the energy levels. But if you understand that as you go further to the right, you have higher energy levels, then I guess that's fine too. And it matches the electron configuration better in a way, and so it matches up with the electron configuration. But I like this way better because you can see that the energy levels are going up. But either way is fine, as long as you know what you're doing. What about problem number 2? So write orbital diagram for argon. So we need to know how many electrons argon has. Argon has 18 electrons. So we could write the orbital diagram again. So we have 1s here, then we have the 2s, then we have the 2p, and then we have the 3s, and then we have the 3p, and then we have the 4s, and then we have the 3d, 1, 2, 3, 4, 5, and then so on. So I think that should be enough. So we have 18 electrons. So we're going to build up. So we're going to put 2 electrons in there, spin up, spin down. Next one is 2s. 2 electrons in there, spin up, spin down. So that's 4. Now we're going to do 6 in the 2p. So spin up, 1, 2, 3, and then pair them up, spin down, 4, 5, 6. Okay, so that's 10 electrons. We have 8 more. So next one is the 3s. So spin up, spin down. So that's 12. And then we have 6 more. So we're going to put them in here. So we have spin up, spin up, spin up. That's 3. We have 3 left. So we're going to do spin down, spin down, spin down. And so this would be the orbital diagram for argon. And so, again, the number of electrons, what are the number of unpaired electrons? In here, they're all paired. So we have 0 unpaired electrons. And so this is the way that you would write your orbital diagrams for a particular element. So if they give you an element and they ask you what's the orbital diagram, this is the way you would write it. And again, you can use also that chart that I drew with the 1s and then the 2s, 2p, 3s, 3p, 3d, and so on. And you could do the diagonal arrows to help you remember what the order is as well. Okay, I hope this was helpful. If you have any questions, you could put them in the comment section. If you like this video, you can tell me what you think. If you like this video, share it. Hit the notification bell so you can get notified of any other videos I put out. And hit the subscription button to the channel if you'd like to subscribe. Thanks for joining me, and I'll see you next time.